All right. This lesson goes over how to calculate expected tables for various bits of data. So our objective is to determine expected values using an expected table for a sample. So if we dive in right to an example here, let's say we're trying to find if there's a difference between introverts and extroverts in terms of employment. And so before we do anything, we need to have our null and alternative hypothesis. The null hypothesis would be there is no difference between introverts and extroverts in terms of employment, while the alternative will just be the opposite of that. There is a difference between introverts and extroverts in terms of employment. And so once we have that out of the way, let's look at our data. Last year, Math 10 surveyed 130 high schooler students, and we asked them whether they have jobs or not, and whether or not they identified as introverted or extroverted. Below are the results. So we have 41 people that were employed, 89 were unemployed, and then out of that sample, 73 were introverts and 57 were extroverts. So the first thing that we're going to do is organize our information like this, where we have our columns and rows. I've organized our columns in terms of employment. So this is our employment column, whether you're employed or unemployed. And then our rows are organized in introverted and extroverted right here. What we're going to do before we do anything is enter in our totals into this table. And so we had 73 total introverts, 57 extroverts. And then in terms of the columns, 41 of people in our sample were employed, 89 were unemployed. And so if the null were true, then the percent of introverts in our sample are going to equal the percent employed. That would assume that our null hypothesis is true, that there is no difference between employment in terms of being introverted or extroverted. And so if the null were true, the way that we can use that fact is with this here. We're going to figure out what percent of our sample are introverts. And we do that by taking our total introverts divided by our total sample. So we had 73 introverts divided by our total sample size of 130. That's 56%. So if our null were true, 56% of the employed should be introverts. And so the way that we calculate that is we just take 56% times the number of employed people we get, and that will give us our expected number of employed people. So I did 0.56, which is the same as 56%, times 41, and that gives me 22.96. And I'm going to write 22.96 right in this cell right here. The next thing we can do, another way I can think about this, is to find the number that goes in here. I go over to the totals. So I take the total in this row, divided by our total sample size, and multiply it by the total in this column. So 73 times divided by 130 times 89 gives me 49.84. And so this is my expected for employed and unemployed in terms of introverts. And I can do the same thing for extroverts. So if I'm finding this cell, I'm going to go over to this total, take this 57 divided by 130, the total sample size, and multiply it by the total in this column, which is 41. That gives us 18.04. And finally, to figure out our final expected for unemployed that are extroverts, we do the same thing we did before. We go over to the total here, 57 divided by 130 times 89, which gives us 39.16. And that's how we determine our expected values in data. Now what I would like you to do is practice this. Get dialed with this. So go ahead and complete the what to expect assignment. It should take you over here, and there are 10 problems where you can determine the expected values for first couple problems. We're talking about left-handed versus right-handed in terms of men and women. And then the latter part talks about several other situations where you determine the expected values. You are now ready to start your assignment.